Good morning, students. How are you? Welcome to my channel. Today I am going to explain about the interference in thin film by reflection. So let us consider a plane parallel thin film. So it is the upper surface of the thin film and this line is the lower surface of the thin film. So here small t is a thickness of the thin film. So let us consider a monochromatic light is incident on a upper surface of the thin film or the point B with an angle of I. Here the incident ray is divided into two parts. So the first one is reflected on the upper surface of the thin film, then it will be form the light ray 1, and second one transmitted into lower surface of the thin film. Again it will be back into the upper surface of the thin film. After that it will be emerges to the upper surface of the thin film, then it will be form the light ray 2. So here BC is the transmitted ray and BE is the reflected ray. Okay, so here we have two types of light rays, that is light ray 1 and light ray 2. So both the light rays are superimposed and produce interference pattern and form the interference fringes. So it is about the theory of the interference in thin film. So now let us calculate the path difference between these two light. To know the path difference between these two light rays, so let us draw the normal DG to BE line. So here BE line is a reflected ray. We can draw the another perpendicular line from D point to BE point here. So here it makes a 90 degrees angle. So here the light rays will travel equal distances from the points D to G onwards is equal to B to C and C to D. To know the path difference between these two light rays, so now I have written that path difference is equal to mu into BC plus CD in film minus BG in air. So where mu is refractive index of thin film here, but here also mu is coming, but in air medium the refractive index of air becomes 1. So let us consider triangle BCH. So from triangle BCH, cos R is equal to, R is a refracted angle. So here H is a 90 degrees. So from this cos R is equal to HC by BC. So I have written that HC by BC. But HC is equal to thickness of the thin film. If we substitute that value, we get BC is equal to T by cos R. So if you know the BC value, then easily calculate the CD value. So similarly from triangle DCH, from the diagram, we can write CD is equal to T by cos R. So now we have same value for BC and CD. So BC is equal to CD is equal to 2 T by cos R. So after that already we know that to calculate the BG, first we can calculate the BD value. So BD is equal to, from the diagram, BH plus HD value. BD is equal to BH plus HD. So from triangle BHC we have to, for same phenomena from tan R is equal to, from this diagram we can write BH by CH, then we get BH by T, then BH is equal to T tan R. So if you know the BH value, then you can write easily HD value. HD is also same thing, that is also T. So already we know that HD is equal to T tan R, and already BD is equal to, you know that BD is equal to BH plus HD. So we can write BD is equal to BH plus HD, that is equal to T tan R plus T tan R, we get 2T tan R. So next let us consider another triangle BGD. From this BGD triangle, D makes an angle I, G makes 90 degrees. So from the triangle we can write sin I is equal to BG by BD. From this we have to calculate the BG value. Then BG can be written as BG can be written as BD sin I. So already we know that from previous one, BD is equal to 2t tan R. We can substitute that value. We get 2t tan R sin I. So according to Snell's law, we know that refractive index is equal to sin I by sin R. So from that, we have to write sin I is equal to mu into sin R. Then BG is equal to substitute that value. We get BG value is equal to 2 mu t tan R sin. So now we have to substitute all these values in path difference equation. So that path difference is equal to, already we know that mu into BC plus CD minus BG in 8. So BC plus CD is equal to 2 mu t by cos R minus 2 mu t tan R sin R from this equation. So from this we have to written as tan R is equal to sin R by cos R. So sin R into sin R is equal to sin square R by cos R. So here the common term is 2 mu t cos R. 2 mu t cos R into 1 minus sin square R we get. So that is equal to 2 mu t by cos R into cos square R. So cos R gets cancelled. So finally we get path difference is equal to 2 mu t cos R. So after that already we know that the interference can be divided into two parts, that is constructive interference and destructive interference. So here from the path difference at the point of B, that is incident light ray, incident at the point B, here there exists some reflection. So the reflected ray additionally undergoes the path difference of lambda by 2. So that's why you can add some value to the path difference for lambda by 2. So the total path difference can be written as 2 mu t cos R plus lambda by 2. So now when the path difference suppose equal to the integral multiples of wavelength means that is a constructive interference. So that constructive interference, already we know that the main condition for the bright fringes is n lambda. So we can write 2 mu t cos R plus lambda by 2 is equal to n lambda. So from this equation we can write 2 mu t cos R is equal to 2n minus 1 into lambda by 2. And for destructive interference, that is equal to of integral multiples of wavelength, that is destructive interference. So that can be equation is 2 mu t cos R plus lambda by 2 is equal to 2n plus 1 into lambda by 2. So if we simplify this equation, then we will get 2 mu t cos R is equal to n lambda. So it is about the interference in thin film by reflection from the constructive and destructive interference. So if you like this topic, please like, share and subscribe the channel. Thank you for watching.